Right. Coming to the next topic. Coming to next topic is evaporation. A special case in a changing state of matter is evaporation. Right. Sorry. Before that, let us discuss effect of pressure. Sorry. Let us discuss effect of pressure. Effect of pressure on change in the state of matter. Right, sorry. So changing state of matter depends on the two factors. One is temperature and evaporation. Up to here we discussed how does the temperature affect the changing state of matter. Now let us discuss effect of pressure. Effect of pressure. Effect of pressure on changing state. Changing state. How does this pressure affect change in the temperature? So the physical state of a substance can also be changed by changing the pressure. Changing the pressure. In other words, when we increase the pressure, there will be change in the state of matter. When we decrease the pressure, also there will be change in the state of matter. State of matter. So, for example, gases can be liquefied by applying pressure by reducing temperature. So, for example, LPG, liquefied petroleum gas, then CNG, compressed natural gas. LPG, liquefied petroleum gas. So, when we increase the pressure on a gaseous molecules, its value will be reduced. Once the value will be reduced, interparticle space become less and there will be change in the state of matter. For example, if we consider a gas in a vessel or a beaker, so imagine that just a gaseous molecules. These gaseous molecules are compressed, or when we apply the pressure on it, so due to increasing pressure, the space between the particles become less. So then what will happen? There will be change in the state. Similarly, so petroleum gas. So it is a petroleum gas, and petroleum gas, when we apply pressure by reducing the temperature, so petroleum gas is converted to liquid, so that we can call as a liquefied petroleum gas. Similarly, CNG also, compressed natural gas. On compression, pressure increases, volume decrease, temperature decrease, then there will be change in the test. Similarly, on gaseous carbon dioxide, when we increase the pressure, it converts into liquid carbon dioxide. liquid carbon dioxide. If we still increase the pressure, then it convert into solid. We can call solid carbon dioxide. The solid carbon dioxide is called dry ice. Is called dry. So by increasing the pressure, by decreasing the temperature, by decreasing the volume, gaseous form of carbon dioxide convert into liquid form of carbon dioxide, then again convert into solid form of carbon dioxide. That solid form of carbon dioxide is called dry ice. Similarly, ammonia gas can be liquefied by applying high pressure and lowering the temperature. So petroleum gas, natural gas, carbon dioxide, ammonia gas also liquefied by applying pressure and by reducing temperature. Right? Solid carbon dioxide is extremely cold substance. It is used to defreeze food and to keep ice cream cold. So in this way we can change the state of matter from one form to another form. So gas to liquid, liquid to gas to liquid to solid. Liquid to solid takes place by increasing pressure, by decreasing temperature. When we increase the pressure, volume decreases. Whereas solid to liquid, liquid to gas takes place by decreasing pressure, by increasing temperature. So temperature increases, pressure decreases, temperature decreases. Whatever, by changing these two factors, we are able to change state of matter. We can change state of matter to one form to another form, or to one state to another state. This is effect of pressure on changing temperature. Now let us discuss conversion. Conversion of temperature. So we know temperature is measured in different units by using different thermometers. Conversion of temperature. Generally, temperature is measured in terms of degree centigrade or Celsius, or degree Fahrenheit, degree Kelvin, degree Reimer or Reamer. So this one question is present. So degree centigrade, degree Fahrenheit, degree Kelvin. So these are the units for measuring temperature. What are those? Celsius, Fahrenheit, Kelvin. Fahrenheit degree, Celsius degree and Kelvin are the different measuring units to measure the temperature. So by using three different thermometers, we can measure the temperature. Let us discuss how. So, this degree centigrade temperature scale or thermometer have two values. Every thermometer has two values. One is lower fixed point and higher fixed point. So this is upper fixed point. This is lower fixed point. Upper fixed point, lower upper fixed point and lower fixed point. So it is lower fixed point. So generally the lower fixed point is melting point of ice. So nothing but melting point of ice taken as a lower fixed point. Lower fixed point. Boiling point of water. Boiling point of water is taken as an upper fixed point or highest fixed point, lowest fixed point water. So in degree centigrade scale or Celsius thermometer, the lowest fixed point is 0, the highest fixed point is 100. So totally 100 divisions are totally 100 divisions. 100 divisions in degree centigrade scale. In case of Fahrenheit, the lower fixed point is 32, the higher fixed point is 212. So in between 180 divisions are. In between 180 divisions. In case of Kelvin, 273 to 373. 273 to 373. Here also 100 divisions are. 100 divisions. Now let us know the relation between. Degree Celsius, Fahrenheit, and Kelvin. Degree Celsius, Fahrenheit, and Kelvin. Conversion of temperature. So to convert the temperature from one unit to another unit, you need to know a formula that is lower fixed point. Not lower fixed point first. Scale minus lower fixed point by upper fixed point minus lower fixed point. Lower fixed point minus lower fixed point. So in case of degree Celsius, C minus 0 by 100 minus 0. C minus 0 by 100 minus 0. That is equal to C by 100. C by 100. In case of Fahrenheit, degree Fahrenheit, F minus 32 by 212 minus 32. That is equal to F minus 32 by 180. F minus 32 by 180. In case of Kelvin, K minus 273 by 373 minus 273. That is equal to K minus 273 by 100. So this way we can know how many divisions are there, how many divisions in each scale. So now let us find the relation between degree Celsius, Fahrenheit, and Kelvin. To know, we need to take scale minus lower fixed point by upper upper fixed point minus lower fixed point is equal to, in other words, scale minus lower fixed point by upper fixed point is equal to lower fixed point, that is equal to scale minus lower fixed point by upper fixed point minus lower fixed point. Lower fixed point. So each one we know. In case of degree Celsius, so here relation between degree Celsius, degree Fahrenheit, degree Kelvin. Scale. First one C, centigrade. Lower fixed point 0 by here upper fixed point 100 minus 0. That's equal to Fahrenheit F minus lower fixed point 32, upper fixed point 212, lower fixed point 32. That is equal to Kelvin K minus 273, K minus 273 by 373 minus 273. That is equal to C by 100 is equal to C by 100 is equal to F minus 32 by 180, that is equal to K minus 273 by 100. So this is the relation. This is the relation between degree Celsius, Fahrenheit and Kelvin. So by changing this, we can find out the relation between centigrade and Fahrenheit and Kelvin. Fahrenheit and Kelvin. Right? So hope this understand. Let us discuss here. So what is the relationship? C minus C by 100 is equal to F minus 32 by 180, that is equal to K minus 273 by 100. Now relation between degree Celsius and degree Fahrenheit relation. Even let us take C by 100 is equal to F minus 32 by 180. C by 100 F minus 32 by 180. 180. See here 0 get cancelled, 2 5s are 2 9. Finally we can write C by 5 is equal to F minus 32 by 9. C by 5 is equal to F minus 32 by 9. This is the relation between degree Celsius and Fahrenheit. Degree Celsius and Fahrenheit. So we can simplify it. For example, we want C is equal to F minus 32 by 9 into 5. If you want to Fahrenheit, F is equal to C by 5 into 9 plus 32. This is the relationship. Then coming to degree Celsius and degree Kelvin. Degree Celsius and degree Kelvin, C by 100 is equal to K minus 273 by 100. So 100 get cancelled. Remaining we get C is equal to K minus 273. K minus 273. From this we can write K is equal to 2 plus C plus 270. C plus 270. If degree Celsius value is given and asked to find out the Kelvin, simply we add 273 to the given degree centigrade. If Kelvin value is given and asked to convert into degree Celsius, just subtract the 273 from given value. In this way, we can calculate. Then next one is degree Fahrenheit and degree Kelvin. So F minus 32 by 180 is equal to K minus 273 by 100. Getting 0 get cancelled. Then 2 nines are 2 5s are. Remaining what we have F minus 32 by 9 is equal to K minus 273 by 5. So this is the relation between degree Fahrenheit and Kelvin. So conversion of temperatures are the very important. So in class 9 we have only conversion between degree centigrade and Kelvin. In the higher studies intermediate, so you have conversion between degree centigrade and Fahrenheit. Then we have another one, Reaver. So it has 0 to 80. 0 to 80. Then no need that one. But you have to keep in this mind. So we discussed effect of pressure and conversion of temperatures from one unit to another unit. Relationships are very important. No lower fixed point, upper fixed point. So lower fixed point nothing but melting point of ice. Upper fixed point is nothing but boiling point of ice. So then if we measure the temperature, in Kelvin, if we measure the temperature in Kelvin, we can call it absolute temperature. We can call it absolute temperature. Absolute temperature is the temperature nothing but if we measure the temperature in terms of Kelvin. In terms of Kelvin, we can call it absolute temperature. Absolute temperature. So this is about the change in state of matter, then effect of pressure and conversion of temperatures.